Welcome, dear children, to today's topic. Today we are going to discuss significant figures. I have slightly changed the order because in doing combination of errors problems, there also we come across the significant figures. So first I thought we will discuss significant figures and rounding off measurement, and after that we will come back to combination of errors. So now let's begin with significant figures. What do you mean by significant figures? See, all these things come in measurement. Okay. So in a measurement, total number of digits, that is reliable digits and last uncertain digit, which are directly obtained from a particular measurement, are called significant figures. So what do you mean by significant figures? Total number of digits. So what we mean by reliable digits and uncertain digit, let's discuss. Let's take some examples. Time measured by a student, 3.6 seconds. An example we are taking. In that 3 is reliable digit, okay, and 6 is uncertain digit. What do you mean by reliable digit and uncertain digit? See, if anybody else repeats that experiment, if the same experimental method, same instrument, everything is same, that means in the same experimental conditions the experiment is repeated, and if the measurement is taken, that the other person may get the measurement as 3.5 second or 3.7 second. So where does that error arise? In that digit after decimal point. Okay, that's what we mean by uncertain digit. Got it? So that is the uncertain digit, and there is no way to have an error in that first digit, that is 3. If same experimental setup and same instrument is taken, there won't be any error in that 3. So that is reliable digit. So in that first example, reliable digit is 3 and 6 is the uncertain digit. In the second example, you just look measurement using another instrument. It is 3.69. So which is the uncertain digit? That 9 comes as the uncertain digit and 3 and 6 are reliable ones. Hope it is clear. Reliable digits and uncertain digit. Uncertain digit, that last digit. Okay. Then time measured by student C. So which is the reliable digit? Which all are reliable digits? 3, 6 and 9 are the reliable digits, and 5 comes as the uncertain digit. So what we mean by significant figures? The total number of reliable digits and uncertain digit. That's what we mean by number of significant figures. Okay. Now, what is the relevance of that significant figures? See, significant figures refers to the limit to which a physical quantity is measured. Here itself we can explain that. In the time measured by student A, the number of significant figures is 3.6. The same measurement repeated by student B by another instrument, he got to be 3.69, where the number of significant figures has become 3. In the case of student C with third instrument, he got it to be 3.695, where the number of significant figures is 4. Okay. So 3.6, 3.69, 3.695. We have already studied about precision in an instrument, not among the measured values. In an instrument, when we compare the precision of instruments, for which reading the precision is more? that I have already told when we discussed precision. Okay, so which one is having more precision? 3.695. The number of places increases, so precision is more. Got it? So actually this number of significant figures shows something about what? Precision. If the number of significant figures is more, the more will be the precision. If it is less, precision will be less. Okay. So we have some examples. Mass 6.11 gram, 3 significant figures. Here the uncertain digit is that 1. Speed 67 km per hour. There are 2 significant figures. Here the uncertain digit is that 7. Time 12.76 seconds. There are 4 significant figures and the uncertain digit is that 6. Length 1.8 centimeter. There are 2 significant figures. The uncertain digit is that 8. Now let's discuss the rules to be followed in determining the number of significant figures in a measurement. The first rule is very simple. That is, all the non-zero digits in a measurement are significant. See, all these rules are applicable for measurement. So, the measurement is always followed by a unit. But in these discussions, for our easiness, we have omitted that measurement and unit. We have simply taken number, but remember, it is always not, this significant figures is applicable for measurements. Okay. So, first one, all non-zero digits are significant. So, examples are given. 16, if a measurement is 16, significant figures is 2. If it is 35.6, it is 3. Okay, 6,438, number of significant figures is 4. Now, the second rule is zeros between non-zero digits are significant. Okay, so if the measurement comes as 205, the number of significant figures is 3. 3008, number of figures becomes 4. Now 60.005. So here comes a decimal point. Okay, but all the zeros between any two non-zero digit are significant. Whether there is a decimal point or not, irrelevant of the position of the decimal point. Okay, all the zeros between non-zero digits are significant. So here the number of significant figures becomes 5. Okay, so here there are 3 zeros between 6 and 5. So number of significant figures becomes 5. Hope it is clear. Now the third one, terminal zeros in a number without decimal are not significant unless specified by a unit. Okay, what do you mean by terminal zeros? That means after the non-zero digits you have 0, and in that measurement you don't have decimal point. So 400, 1600, etc. So in such measurements, that trailing zeros are non-significant. So example, if the measurement is written as 400, the number of significant figures is only 1. Okay, 3050. So here you have to apply 2 rules. There is a 0 between non-zero digits. That 0 is significant. This 0 is significant, but that trailing 0 is not significant. That's what we mean. Okay. Now what we mean by unless specified by an instrument, least count of an instrument. Here in the last reading it's written 20 plus or minus 1. So that plus or minus 1 in what form it is written? That quoted value form. We discussed in the previous day, in a measurement, this is the quoted value form. So in that 1 stands for what? That error, possible error. So it is, what does it mean? The measured value can lie between 20 minus 1 and 20 plus 1. So it can be either 19 or 21. Got it? So in such cases, that 0 becomes significant. Okay, if it is written like this, that 0 becomes significant. So if it is simply written 20 second, that 0 is not significant. 20 plus or minus 1 second, that 0 becomes significant. Now, terminal zeros that are also to the right of a decimal point in a number are significant. Terminal zeros to the right of a decimal point. So, in a measurement, if there is a decimal point, to the right of the decimal point, how many zeros comes? What all zeros come? The trailing zeros. That's what we mean by terminal zeros. The trailing zeros, they are significant. For example, 64.00, those two zeros are significant. 3.60, that 0 is significant. 25.060, so here you look, both the zeros are significant. First 0 comes between two non-zero digit and the last one is trailing one after decimal point. It is significant. So if the same zeros come without a decimal point, no, those zeros, they become non-significant. For example, if it is 6,400, number of significant figures, it will be 2. 3.6, instead of 3.6, 360, if it is only 2, like that it becomes 25,060 if it is only 4. Got it? So if the decimal point is there, the zeros which come to the right side of the decimal point after that means after the decimal point, then those trailing zeros are significant. Now coming to the fifth rule, if the number is, that means measurement is less than 1, all zeros before the first non-zero digit are not significant. So very important. So if you have measured values like this, less than 1, so 0.1, 0.001, like that it comes, no. In such measurements, the zeros which comes after the decimal point, okay, all the zeros before the first non-zero digit are not significant. Got it? So in the measurement 0.0064, the number of significant figures is 2. 0.0850, number of significant figures is 3. And in the last one also the number of significant figures is 4. So you understood, trailing zeros after non-zero digit, which all trailing zeros are coming, that is significant. But before first non-zero digit, which all zeros come, that are not significant. Now sixth one, it is an important rule. During the conversion of units, use powers of 10 to avoid confusion. Okay. Or in other words, we can say a choice of change of different units should not change the number of significant digits or figures in a measurement. That means even if we change the units, system of units, it should not change the number of significant figures, because number of significant figures shows the precision with which we measured the value. Got it? So here example has been given, that is, if we write the measured value as 2.700 meter, number of significant figures is 4. Okay. So if we simply convert it into centimeter, what will you get? If you are converting it into centimeter, you will multiply it with 100. So you will get 270 centimeter. Is it not? If you write 270, what is the number of significant figures? Number of significant figures becomes what? 2. 270 you are writing. 270. If you are writing 270.0, you will get the number of significant figures 4. Otherwise, we are writing what? 270. If you simply write 270, the number of significant figures becomes 2. Got it? So to avoid such confusions, we should write a measured value in the form of what? Powers of 10. Got it? So number we are writing 2.700 meter. No need of power there. Number of significant figures is 4. When you convert it into centimeter, how you have to write? 2.700 into 10 to the power 2. That much centimeter. So even if the power of 2 comes, what is the number of significant figures in that measured value? It is again 4. Got it? Then converting it into kilometer, that means 2.7 meter itself we are converting into kilometer. So you have to divide it with 1000. Dividing by 1000 means dividing by 10 raised to 3. So it becomes what? 10 raised to minus 3. So 2.7 into 10 raised to minus 3 kilometer. Again the number of significant figures becomes 4. So when you change the system of units, okay, you should pay attention that the number of significant figures remains unaltered. Okay, if such confusions comes, you have to follow quoting the measurement like this in powers of 10. The way of writing the measured values in this form, the power of 10, is known as standard notation or scientific notation. It is the scientific notation. So in scientific notation, we will express the measurement as what? Powers of 10 in the form a into 10 raised to b. In the form a into 10 raised to b, we will express the measurements. So reporting the measurement in scientific notation means like this. Okay. So I would like to make it clear that scientific notation. Okay. So we said to remove the problems of change in the unit, the best way is to report all the measurement in scientific notation. So what is that scientific notation? Writing the measurement in the form a into 10 raised to b. In this form, writing the measurement is called as scientific notation. Here a will be a number between 1 and 10. That way you have to write. You cannot write any number there. When you write the measurement in scientific form, you should write a as number between 1 and 10. And b comes as the power of 10. So it can be either positive or negative. Okay. So there that b is called as order of magnitude. In what context we use that word order of magnitude, we will explain. So with some examples, we will discuss this order of magnitude. For example, diameter of earth is 1.28 into 10 raised to 7 meter. So we say diameter of earth is of the order 10 raised to 7 and order of magnitude is 7. So what comes as the power of 10, that power we write as the order of magnitude. Okay. Diameter of an atom is 2.6 into 10 raised to minus 10 meter. So it is of the order 10 raised to minus 10 and order of magnitude is minus 10. Nucleus of an atom 1.6 into 10 raised to minus 15 meter and it is of the order 10 raised to minus 15 and order of magnitude is minus 15. So generally we said in scientific notation a number or a measurement is written in this form a into 10 raised to b where a lies between 1 and 10. Okay. So what will be the order of magnitude? There are two rules. See, if the value of a is less than or equal to 5. Okay. If a is less than or equal to 5 like 4.2, 3.6 etc. then order of magnitude is this power of 10 itself. B itself is taken as the order of magnitude. If a is greater than 5 and less than or equal to 10. Okay. So if a is greater than 5 and less than or equal to 10, then the order of magnitude we have to take as b plus 1. So that is the case. Okay. If the value of a is greater than 5 and less than or equal to 10, then the order of magnitude becomes b plus 1. Example, 4.7 into 10 raised to 3 meter. Order of magnitude is 3 itself because here A is less than 5. 9.1 into 10 raised to minus 31 kilogram. Okay, so here A is greater than 5, then it is to be raised by 1, order of magnitude. So minus 31 plus 1, so it becomes minus 30. So these 2 points we have to take care of in finding order of magnitude. So that's what we were discussing. To avoid confusion, when you convert the system of units, use powers of 10. Okay. Now coming to the last point, that is, so as I was telling, whatever we were discussing about measurements. To avoid confusion, we have written like numbers, but if you are writing a measurement without a number, it means that it is not a measured value, means without unit, it means that it is not a measured value, it is simply a number, a constant value, like pi. What is pi? 3.14. So it is not having any unit. Okay. So we say that it is having infinite significant figures. Got it? So simply if you are writing any number 2, 3, 4, etc. without unit, it means it is a constant value or a number which has infinite number of significant figures because they are that much reliable. For example, 45 students, it has infinite number of significant figures in that. 5 apples, 6 faces of a cube, all those numbers, they don't have any unit, so they have infinite number of significant figures. Okay, so 1 hour 60 minutes and all such things, they have significant figures. But if we simply say a unit, so in the case of what surface area of a sphere, 4 pi r square. Okay, in that 4 and pi are there. 4 is not having any unit, so number of significant figures is infinity. Pi is also not having any unit, so number of significant figures is infinity. In the measurement r, radius, there comes number of significant figures. Is that clear? So there are constant values or numbers which we consider as exact numbers which do not have any number, that means which have infinite number of significant figures. Here are some examples of finding significant figures. Here are some examples of finding order of magnitude. Now, there are some rules for arithmetic operations with significant figures that we will be doing in the next session. Okay, all the rules we will not do today, but try to understand in the previous days sessions also, while we were doing calculations, we were coming across rounding. So certain places I used the word rounding. So now we are discussing, it's very simple, the rules for rounding of the uncertain digits. Okay. So what is the first rule? So the thing is this, if in a measurement or after doing calculations, if after decimal point many numbers, many digits come, certain digits we have to eliminate. For that purpose only we do what? Rounding. Okay, so examples we will take. So first rule, what is the first rule? If the digit to be dropped is less than 5, then the preceding digit is left unchanged. Okay, so with examples only we will discuss. So the number or the measurement is 64.62 and we have to round off it up to 3 significant digits. So in the measure, when we write the measured value, there should be only 3 significant digits. Okay. So this type of situation arises especially when we do error analysis. In error analysis, there are what we will be finding average value, no. So when we find average value, that in average value there may be many decimal points. That means after decimal point many digits will be there. So that time I told how many places are there in the what measured value. Only that many places you have to retain in the mean value also. So there you have to apply rounding. Okay. So when you apply, that means to that much significant figures, if that number to be dropped. So here in the first example 64.62, okay, we have to round it up to 3 digit, means that 2 is to be rounded. So that number to be dropped, if it is less than 5, you simply drop that number. Got it? If the digit to be dropped is less than 5, simply drop that number without making any change in the preceding digit. Which is the preceding digit here? 6. Just before 2, which digit comes? 6. Okay, so that 6 remains unchanged. So that value becomes what? 64.6. Next is 3.651. Here the number to be dropped is 1, because our aim is to get 3 digit in significant figures. So that 1 is simply dropped. 546.3. So number to be dropped is 3. It is simply dropped. Hope it is clear. First one, rules for rounding. If the digit to be dropped is less than 5, then simply drop that number without making any change in the preceding digit. Now coming to the second rule, if the digit to be dropped is more than 5, then the preceding digit is raised by 1. Okay, so here the digit to be dropped is greater than 5. So example 3.479. So here required significant figures is again kept as 3. So 3.479. Here the number to be dropped is 9, which is greater than 5. So what to be done? The preceding digit is to be raised by 1. So here the preceding digit is 7. So it becomes 8. So 3.48. Next example 93.46. So that number to be dropped is 6. So preceding digit is to be raised by 1. So 93.5. 683.7. Number to be dropped is 7. So preceding digit is raised by 1. 684. Hope it is clear. Now coming to the third rule. If the digit to be dropped is 5 followed by digits other than 0, then the preceding digit is to be raised by 1. Okay. So here we have an example. With the example we'll explain. 62.354 and round off to 3 digits. In the after rounding we need only 3 digit. Okay. So number to be dropped is 5, but that 5 is followed by what? 4. So after 5 there are some digits. In such cases, that means the position where it is to be dropped, there the number 5 comes and that 5 is followed by some digits. In that case, the preceding digit is to be raised by 1. So in this case it becomes 62.4. Second case 9.6552. So 5 is followed by some numbers. So the preceding digit is what? Raised. So it becomes 9.66. So in the third example 589.51. So number to be dropped is 5 followed by 1. So preceding digit is raised by 1, giving the result 590. Now coming to the fourth rule, if the digit to be dropped is 5 followed by 0 or nothing, the last remaining digit, that means the preceding digit, is increased by 1 if it is odd, but left as it is if it is even. So here we need more clarification. With examples we will do. So in the previous rule, if the number to be dropped was 5 followed by some numbers. Here number to be dropped is 5, but it is followed by 0 or nothing. Okay. In such cases, when you drop that 5, you have to look at the preceding digit. If it is odd and even, two separate rules we have. So, first example we will take 53.350. Here also our requirement is 3 digit. Number to be dropped is 5, which is followed by 0. So, you look at the preceding digit. Preceding digit is what? 3. Okay, that 3 is an odd number. So the rule says if the preceding digit is 3, you increase it by 1. If it is even, if it is even number, you just drop without making any change. So here since it is 3, since it is odd, we have to raise it by 1. So our measurement becomes what? 53.4. Come to the next one, 9.455. Here also our requirement is 3 digit. So number to be dropped is 5 followed by nothing. So you have to look at the preceding digit. Okay, preceding digit is which one? It is 5. So it is odd. So it is to be raised by 1. So it becomes 9.46. Coming to the next, 782.5. Number to be dropped is 5. Preceding digit is 2. Preceding digit is 2, which is an even number. Okay. That even number is to be left unchanged. So after rounding our measurement becomes what? 782. That's the case. Hope it is clear. The rules to be followed. So that means if the number to be dropped is less than 5, simply drop. Then if it is greater than 5, then increase the preceding digit by 1. If it is 5 followed by some numbers, then also increase the preceding digit by 1. If it is 5 followed by nothing or 0, then you have to look at what is the preceding digit. If the preceding digit is odd, increase it by 1. If it is even, leave it unchanged. Okay, so these are the rules for rounding. Only this much for today. Thank you.